Continuing the same problem. Yeah. So we'll continue, and then A inverse into A is equal to I into X is equal to A inverse B, and we know that I into X is nothing but X only, its identity. So X will be equal to A inverse B. So now we have X is equal to A inverse B. So now if we kind of find the value of A inverse, see, we need to find out the value of X. B ka value we already know, B matrix. And this A inverse ka matrix, if we find it, then easily we can find out the value of X, right? So what we will do now, we can find out the value of A inverse. Okay, so let us find it out using um, transformation. Okay, row transformation. You can use any method for finding out A inverse. You can even use adjoint method. That is also okay. So A inverse using transformation. Abhi adjoint we just did it, no, in the beginning of the previous video. So let us do it using row transformation first. So row transformation ke liye, that is something we did it last time. A into A inverse is equal to Y. So A will be equal to, as it is, 2, 6, 3, 2. A inverse, since this is of order 2, 1, 0, 0, 1 will be the identity. Okay. So what did we do after this? What is our aim? Our aim is to make this identity, and then whatever operations we perform on this matrix, we will also perform it on this matrix, and then finally we'll get the answer of A inverse. Yes. So what was our first aim? Our first aim was to make this 1, right? Last time I told you the procedure how we have to do it. 1 we will make this, and then isko 0, and then 1, and then 0. So let us make R1, right? So this is the first row. So R1 can become half times R1. So then R1, when you divide it by 2 only, then it becomes 1, correct? So then 2 divided by 2 will be 1. 3 divided by 2 will be, actually it's 1.5, but you can write fractions. Row 2, there is no change. We will write it as it is, 6 and uh, second, what was that value of A? It's minus 2. Okay, 6 and minus 2 as it is. 6 and minus 2 as it is. And then A inverse, which is equal to, as I said, whatever rules you will be performing for the first matrix, you will be performing it for the second matrix also. So this is 1. So this becomes 1 by 2. This is 0. 0 by 2 is same as 0 only. Now we will try to make this 0, right? We want to make this 0. When can I make this 0? 6 minus 6 gives me 0, correct? More easily. So 6 minus 6 times row 1. I can see the difference, right? We had solved many sums of this type last time. Here we have 6 and here we have 1. So 6 minus 6 times 1, right? So that is nothing but 6 minus 6 times row 1, correct? So row 2 we want to change as row 2 minus 6 times row 1, okay? Now row 1 there is no change, so let us write it as it is. So row 1 is 1 and 3 by 2. Row 2 is 6 minus 6 times, and this is minus 2 minus 6 times 3 by 2. 3 ones are 3 threes are, so this is minus 2 minus 9, that's minus 11 into A inverse, which is equal to half, 0, 0 and 1. Okay. So that's what we get. And now we kind of making this, just a second. This is 6 minus 6 9, no? So this has become 0. Okay. So now the next thing is making this also. Just a second. R2 is like R2 is like this, minus 6 times R1. So this is 0 minus 3 ones are 3 twos are. 2 ones are 2 threes are. So that's 0 minus 3 is minus 3. The next one is R2 minus 6 times R1. So that's 1 minus 0, which is equal to 1. Now we have to make this 1, correct? So anything you want to make it 1, the very easy way I've told you is dividing by that same number. जैसे यहाँ पे 2 था तो हमने divide by 2 किया तो we got it as 1, right? So likewise here also R2 changing to minus 1 by R1 into R2, correct? That's what we're doing. And then R1 there is no change. Let us write it like that. This thing divided by minus 1 by 11 है तो इसको हम क्या करेंगे, 0 है तो there is no difference. This is minus 1 in minus 11 into minus 1 upon 11. So that's 1 A inverse. Row 1, no change. Row 2 is minus 3 into minus 1 by 11. So that becomes 3 by 11. This is 1 into minus 1 by 11 is minus 1 by 11. Okay. Now the last thing, what was that last thing to make इसको 0, correct? 3 by 2 को. Any number making it 3 by 2 को 0 with the help of that opposite wala 1. So that's much easier. So row 1 ko we want to change. How are we changing? Row 1 minus 3 by 2 times row 2. Okay, because then it will be 3 by 2 minus 1 into 3 by 2. So 3 by 2 minus 3 by 2 will be easily, it will give us 0, correct? So row 1 is undergoing a change. Row 2 will be as it is, which is equal to, so R1 minus 3 times 0 by 2. So minus the 3 0 by 2, that is going to remain the same. 1. 3 by 2 minus 3 by 2 is 0. Now R uh, 1, right? R1 minus 3 by 2 R2. So this is half minus 9 by 22. Okay, so half minus 9 by 22. How will we do this? So you can do it into 11 into 11. So that is 11 minus 9 upon 22. And then that will be 2 by 22, right? The first one will be 2 by 22. The second one is R1 minus 3 times R2. So R1 minus 3 by 2 times R2. That's minus 1 upon 11. What is the answer? 0 plus 3 ones are 3 upon 22. So the answer is 3 by 22. So that's 3 by 22. R2, there is no change. We will write it as it is. Okay. Now, this is identity into A inverse. So we know that A inverse is nothing but this full thing, 2 by 22, 3 by 22, 3 by 11, minus 1 by 11. All right. Now what the thing is, you can always take that denominators. If you see, that's 11 and 22, and we can always take that minus 1 by 11 common everywhere, right? So 1 by 11 you have taken common from here. So what remains? 1 by 11 if we take out common from here, so then we get 2 by 11 may say 1 2 by 22 may say 1 by 11 we have already taken, so that becomes 2 by 2, correct? So that is what remains. So 2 by 2 is nothing but 1. Okay, and then this is 3 by 22. 3 by 22 may say divided by 11 we have taken outside from the denominator, so what remains? 3 by 2. Here again 11 we have taken common, so this is simple because the denominators have it's completely come out. So this is what is the value of A inverse. Okay. Now why did we find out A inverse? Did they ask us to find out A inverse? No, they didn't ask us to find out A inverse, but we wanted to find out A inverse because of this equation, right? We were dealing with this equation and this equation. So x was equal to A inverse B. So अगर हमको A inverse का value easily मिल जाता है, तो x का value will easily find out. So x is equal to A inverse B that we initially had, right? Since we had x is equal to A inverse into B, A inverse will be this full thing, 1 by 11, 1, 3, 3 by 2, minus 1 into B, right? What was B? B initially we had written, no? B was 5, 4, right? Okay, 5, 4. All right. So after doing this, now it's like normal multiplication. So what we can do is we can multiply this two. Let that 1 by 11 be aside, and we have to multiply these two. So what is the for this thing of multiplying? This ka order is 2 rows and 2 columns. 2 rows, 2 columns. Iska order is 2 rows and only 1 column. So these two things are matching, so we can always multiply. And the resultant will be of this order, 2 cross 1. So this will be 1 by 11. Let us keep it as it is. Let us multiply now. How will we multiply? First row into first column, right? First row into first column and then element wise. So we isko और इसको multiply करना है. In element wise, 1 into 5 is 5 plus 3 by 2 into 4. What is 3 by 2 into 4? 2 ones are 2 twos. So that's 3 into, right? So 3 twos are 6. Okay. And then now first row into what is this? first column, first row into first column. So that is 3 5s are 15 minus 1 into 4. So that is 4. Alright. So this is the answer. So this will be 1 by 11 into 5 plus 6 is 11. 15 minus 4 is again equal to 11. So then what we get? We are throughout like dividing it by हमने पहले 22 जब था 11 तब था तब हम भी common लिया था 11, right? So अभी we have that 11, and in case if we multiply that 1 by 11 to each and every element inside, 11 into 1 by 11 always gives us 1, right? So 1 1 at both the places. 11 into 1 by 11, 11 11 cancel. इसके लिए भी और इसके लिए भी. So then this is the final answer. What is this, by the way? What did we calculate? हमने calculate किया था x का value, right? So everywhere this whatever we calculated what x. But what was x initially? X was nothing but x and y, right? X and y. So x and y ka values are 1 and 1 respectively. Hence we get x is equal to 1 and y is equal to 1. That is nothing but the solution of this equation. Otherwise, for solving it simultaneously doesn't take more than 2 minutes. This of course takes time, but that is how you have to do it using matrices. Okay. So now let us do it for order 3. Order 3 ke liye now 3 equations and 3 unknowns. Please remember the procedure. This is again by inversion method. You have this equations. Now we'll write that a x is equal to b. So where a is equal to 1 2 1 minus 1 1 1 1 minus 3 1. X will be equal to x, y and z now, right? And then b will be equal to 4 0 2, the constants. Okay, so then after this you're going to write that ax is equal to b, and then 3 multiplying by a inverse. You're going to write those steps. Okay, so few steps which you have to complete, which we have already written it twice, so I'm not writing. What will you get? X is equal to a inverse b. Okay, so abhi we have to find out value of a inverse. A inverse, you can do it as I said using any method, either using that transformation or using adjoint method. So we did it using transformation in the previous sum. So let us do this using adjoint method now. So what is A? By the way, A is this matrix. 1, 2, 1, minus 1, 1, 1, 1, minus 3, 1. So we're going to find out the determinant of this matrix. What is the determinant of this matrix? 1 into this row and this column you're going to hide, and then whatever remains 1 1 minus 3 1. So there that becomes 1 into 1 is 1 minus this is what 1 into minus 3, so that becomes plus 3. And then यहाँ पे we're going to change the sign. 1 into ये row और ये column हमने hide कर दिया, so that is 2 1s are 2 minus of 1 into minus 3 is minus 3, but that second wala we change the sign. If you're not okay doing it like this, I mean quickly, so you can always break that into steps like how I did it in the previous sum, in the 2 3 sums back. So you just check on that. Okay, so this row and this column gets hidden. 2 1s are 2 minus 1, right? Okay, so what is the value of this determinant? 4 plus 5 plus 1, so that's equal to 9 plus 1 10, which is not equal to 0. So since determinant A is not equal to 0, which implies A inverse exists. Alright, so yes, A inverse exists. Now let us find it out, but let us do it using adjoint method as I said now. So A ka matrix that you have, what is the A matrix? 1 2 1 minus 1 1 1 1 minus 3 1. This was the matrix. And we last time how we did, as I said, first sometimes we wrote minus and then we did cofactors. But let us try it using cofactors only first, because cofactor ka this is the formula जिसमें minor आ ही जाता है. There is no point that you calculate it separately. We're going to do it element wise. So what is for the first element? A11, that is nothing but this element, right? This element, this one and this one. So after this one and this one, when you ignore, what do you get? You get 1 1 minus 3 and 1. So what is the value? 2 ones are 1 ones are 1, and then 1 into minus 3 is minus 3, minus of minus 3 is 3, that is equal to plus 4. Now this was the value of the minor, minus 1 raised to 1 plus 1, right, into the value of the minor that you had written. 1 plus 1 is 2, so the sign will not change. I've told you already कि किसका sign change होता है किसका नहीं होता है. This is 1 plus 1 2, the sign will not change. Okay, now what will be a 1 2 minus 1 raised to 1 plus 2 into mij. इसके लिए is the sign going to change? Yes, it is going to change, right? 1 plus 2 is 3 odd, so it is minus the sign is going to change. So a1 2 में this one and then this one we're going to ignore. What remains? 2 1 minus 1 minus 3 1. So what is the answer? 2 ones are 2, minus of 1 into minus 3 is minus 3. So here we get the answer as 5. But we know that the sign is going to change now, so we will change the sign. Next one, A13, A13, 1 plus 3 is 4, sign will not change. Okay, A13 ka this is the position, ye row and ye column we're going to this thing. So you get 2, 1, 1, 2, 2 ones are 2, minus 1 into 1 is 1, so that's 1, 2, 1, 1, right? Yeah, and the sign is not going to change. 1 second, let me just erase this. You have to write that, of course, in the exam, as I did it in the previous sum. Yes. Now for A2, A21, A21 with the 2 plus 1 is 3. So sign will change. This is second row, first column, this much. So what remains? 1, minus 1, 1, 1 and 1. This is minus 1, minus 1. So this is minus 2 and the sign will change, right? A22 will the sign change? No, A22 sign will not change because 2 plus 2 is 4 and 4 is even. A22 ka this is the element. This row and this column getting cancelled. 1, 1, 1, 1. What is the value of 1, 1, 1, 1? 1 ones are 1 minus 1. So that's equal to 0 only. So we'll keep it 0. So A2, 3. 2 plus 3, 5. Yes, sign will change. This element. This row and this column को average करके whatever you get 2 1 1 1. That's 2 1 1 1. 2 ones are 2 minus 1 into 1 is 1. So that's answer is 1, but the sign will change as I said, so that will become minus 1, right? Just a second. Just a second. So this will be like this. Oh, 8 seconds. A23. This is the element, right? Second row and third column. This is the element. So then after ignoring this, after ignoring this one and after ignoring this one and this one, whatever we get, so that becomes 1 1 minus 1 and 1, right? So A2 के लिए we have A23 के लिए 1 1 minus 1 and 1. So its answer is 1 ones are 1 minus of this is minus 1. So the answer is 2 actually, but we know that the sign is going to change, so it will be minus 2. Let me quickly write it for A13, A31, A32, A33. I suppose you have understood the steps. This is 2, this is 5, and this is 3. Okay, so now what was the next step? Our next step was to write the cofactor matrix, right? So this is the cofactor matrix. Matrix, we write it like this. What is the answer? 4 minus 5 1, 4 minus 5 cofactor 4 minus 5 1. Next one is 2 0 minus 2, 2 0 minus 2, 2 5 3, 2 5 3. Yes. Now what will be the adjoint of A? Adjoint of A is nothing but transpose of the cofactoric matrix. 2 minus 5 1, 2 0. What was this? 2, right? Yeah. 2 minus 2, 2 5 and 3. Okay. After this, we're finding out the inverse. Inverse is nothing but 1 upon into adjoint A. So this is 1 upon, what was the value of the matrix? I think it was 6. No, 10. Okay. So 1 upon 10 into that adjoint. 4, 5 minus 4 minus 5, 1, 2, 0 minus 2, 2, 5, 3. This is the inverse. Now why did we find out that inverse for? Because we wanted to find out the values of x. So that's A inverse is 1 by 10 into 4 minus 5, 1, 2, 0 minus 2, 2, 5 and 3. B ka values are the constants. Those were 4, 0 and 2 according to the question. So we're just going to multiply them, multiply these two. So what will we get? This is like 3 cross 3. This is 1, 2, 3. 3 rows and 1 column. So these two are equal. So we can multiply and the resultant will be of order 3 cross 1. Okay. How are we going to multiply this? This into this. First row into first column. 4 for the 16. 2 into 0, 0. 2 twos are 4. Next one. Second row into first column. Minus 5 into 4 is minus 20. Plus 0 into 0 is 0. Plus 5 twos are 10. Next one. This into this. 1 into 4 is 4. Minus 2 into 0 is 0. Plus 3 into 2 is 6. This is nothing but 1 by 10. And what are the answer is 16 plus 4 is 20. This is minus 20 plus 0 plus 10. So the answer is minus 10. 4 plus 6 is 10 again. So when you divide throughout by 10, you get 2 minus 1 and 1. Right? What was this? This was nothing but x, right? So x, y and z is 2 minus 1 and 1, which implies x ka values 2, y ka values minus 1, z ka values 1. Okay, so that you have to remember. Okay, that's always goes in that order. So the next one is nothing but using method of reduction. Reduction is again like very simple. This was method of inversion that we did. उसमें क्या करना होता है? उसमें similar to row column transformation, but you'll do it using row transformation only. So second method, let us see if we are able to, how much we are able to do. Second one was method of reduction. अभी तक हमने जो भी किया था that was method of inversion. All right. So method of reduction में how will you do it? It will be the same. You have to write it in the matrix equation form. Ax is equal to b, and then finding out the values of equation using some kind of row transformation. Suppose this equation we have 2x minus y, which is equal to minus 2, and 3x plus 4y, which is equal to 3. Okay. So इसमें से we have to do this using method of reduction. Ax is equal to b, right? This is what we have. What is a? A is 2, 3, minus 1, 4. X is y, x and y, and that is equal to minus 2 and 3. Okay. Now what we will do is, this is our x, correct? This is our x, and this is our a, and this is our b. So our major aim is to make this either into an upper triangular or a lower triangular. Okay. Upper triangular or lower triangular, you've already done it in the types of matrices, but I'll just quickly tell you what is upper triangular, what is lower triangular. This is the diagonal, correct? Okay. So upper triangular means when all the lower triangular are equal to 0. This is diagonal, this is lower, this is upper. When can it be called an upper triangular? When the lower triangular element is 0. Or else when it is called as lower triangular, when the upper triangular elements are 0. Suppose if you have something like this, 0 and minus 1. This is the diagonal. Okay. ये lower triangular है और ये वाला 0 है. So then this will be called as an upper triangular and vice versa. So इसमें you have to either make it a lower triangular or you have to make it an upper triangular. Okay. So let us see what is more easy for us. As I gave you that example, ये diagonal है. इसके नीचे वाला अगर हम इसको 0 बना देते हैं, then we can easily find out the value of that equation. Okay. Now suppose if we have, as I said, you were doing it using reduction. तो जैसे अब so as I said, you can't now directly make this upper triangular or lower triangular, correct? So इसको बनाने के लिए what we can think is, as I said, यहाँ पे अगर हमको easily 0 मिल जाता है, हम easily find कर सकते हैं. But यहाँ पे 0 होना, it is not very easy. See, 3 था यहाँ पे, अभी तक जैसे भी 3 होता था हम इसको 1 कर देते थे, तब हम लोग इजीली उसको 3 we can make out, but we can't do that. So what we will do is, we have many ways of doing, as I said. I will try to divide. Okay, I'll try to subtract. R2 changes to R2 minus R1. Okay, R2 changes to R2 minus R1. There is no change in R1. X and Y as it is. This will be minus 2. R2 minus R1. 3 minus 2, 1. 4 minus of minus 1, that is 5. 3 minus of minus 2, that's 5. Okay. Now, as I said, we want to make this 1. What we can do is, now if we do R2 minus R1, okay, sorry, R1 minus R2, we can get this as 1. Are you able to recollect? See, R2 minus R1 minus R2, 2 minus 1 अगर हमने किया तो यहाँ पे 1 आ जाएगा. So the next step, 1 minus 1 तो easily 0 मिल जाता है. So what I do is, R1 changing to R1 minus R2, okay, XY as it is. Now the change is R1 में. So R2, let us write it as it is. R1 minus R2. 2 minus 1 is 1. Minus 1 minus 5 is minus 6. Minus 2 minus 5 is minus 7. Okay. Now let us do it. R2 minus R1 or R1 minus R2, whichever you want, you can do it, so that you will get this one as 0, right? R2 changing to R2 minus R1. R1, there is no change. R2 minus R1. 1 minus 1 is 0. 5 minus of minus 6 is plus 11. 5 minus of minus this thing is plus 12, correct? So this is what we are getting, alright? So now we will just try to write the equations like this. ये क्या है? हम इसको हमेशा multiply कैसे करते हैं? This is order 2 and this is like 2 cross 1. So we're going to multiply it like normal numbers. Consider x and y as normal numbers. So this will be 1 into x is x, plus minus 6 into y is minus 6y, right? Okay. This is equal to the first equation. So that is nothing but minus 7. And the next one, 0 into x is 0, plus 11y, which is equal to 12. Okay. So y answer, what do we get? Y is nothing but 12 by 11. So let us put it in the equation number 1 and get the value of x. X minus 6 times 12 by 11, which is equal to minus 7. X minus 12 6 are 72 divided by 11, which is equal to minus 7. Okay. So this is nothing but x will be equal to minus 7 plus 72 by 11. So x will be equal to minus, cross multiplying, minus 77 plus 72 divided by 11, which is equal to minus 5 by 11. Okay. So you can do it in any order. So we'll get the answers of x and y as minus 5 by 11 and 12 by 11 respectively. So that's the solutions. Textbook, they have used other type of transformation. I have used other type of transformation. As I said, using any type of transformation, if your calculation is correct, it is absolutely okay. All right. So next lecture, we will do it. We'll continue with method of reduction only, but we will do it for 3 equations, 3 unknowns. Okay.